Let's start with the sensor interfacing. Learn how to interface sensor with the microcontroller and how to use sensor in the real life applications. So we are going to start with the sensor interfacing today. So before going to start, let's see why to use sensors only. So the sensors actually are the kind of device which enhance the process, or you can say gathering data is a common feature of practical work in a school science laboratory. Sensor technologies can enhance this process in many ways. The data gathering is converted to a digital form and is processed at high speed. The data is subsequently retrieved and processed whenever and however the scientists want. The term data logging is widely used to describe what sensors technology does. These technologies can offer greater speed and endurance. Therefore, there is a great potential for it using science experiments. By automating the process of taking measurement, it can reduce the amount of tedious repetitive tasks and increase efficiency. So, this is why we are using sensors. Let's see what are basically a sensor is. Sensors are sophisticated devices that are frequently used to detect and respond to electrical or optical signal. Sensors actually converts the physical parameter into a signal which can be measured electrically. Or you can say, if you want to measure your temperature or blood pressure, so you are using actually a temperature sensor and the pressure sensor for measuring this. So that's why we have to use sensors. Alternatively, sensors technology can display graph of data in real time. The graph is constructed as the data is being collected, and the graph is then modified on the screen as the data is processed. So this is what our sensors actually is. Now we come to the point, what is the criteria to choose a sensor, because at different criteria there might be a different sensor. For, let's suppose, take an example, if you want to measure a pressure, so for measuring pressure of blood, or if you want to measure pressure of air, so there are different pressure sensor. So according to the condition, according to accuracy, according to the environment, range, calibration, resolution, you have to choose the sensor. So the first criteria is accuracy, means up to which accuracy you want your sensor is, so it's depend upon that. Second is environmental condition, means in which condition your sensor will going to work, usually has limits for temperature and humidity. Range means measurement limit of sensor, up to which limit your sensor will work. Like if you want to measure the blood pressure, so it will vary from 70 to 180, 190. So it means to say from lower limit to upper limit of the sensor. Calibration essential for most of the measuring device, as the reading changes with time. Calibration is means to say the reading changes with time, or you can say in the real time. It's actually depend upon the changes in the environment. So in this way the calibration is used. Resolution, smallest increment detected by the sensor, means to say if you have a any temperature sensor and there is a rise or fall in few degrees in the temperature sensor, so it must and should have detect that increment or decrement. So this is actually a resolution is. Fifth is cost. Cost is a major factor because it's depend upon you which kind of sensor and which type of how sophisticated sensor you want to use, so it's depend upon its cost. Repeatability, so the reading that varies is repeatedly measured under the same environment, means to say the sensor which is work continuously, or we can say which works repeatedly one by one using day by day and year and so on. So that is the best sensor which you can use. So these are the criteria to choose a sensor. Next we are going to see the classification of sensor, in which types we can classify the sensors. So the first classification is depend upon the primary input quantity, means to say what type of input we want to give to the sensor. So on this way primary input quantity sensors are classified. Transduction principle, using physical and chemical effects, means to say using physical and chemical effect which type of sensor you can use, like for temperature sensor, moisture sensor, or smell sensor. So these are physical conditions, and for water sensor, for chemical sensor, for acid sensor, they are chemical use. Material and technology, what kind of material we are using and what are the kind of technology we are using. Property and the application. So in this way we can classify the sensor on the 5 conditions. In our GyanX do-it-yourself kit, you will find 7 type of sensors. First is Hall sensor, second is temperature sensor, then digital infrared sensor and the analog infrared sensor, light sensor, sound sensor, vibration sensor, and pressure sensor. So these 8 sensors you are going to find in GyanX DIY Kit. For this you have to subscribe and log in to www.gyanx.com and subscribe for AVR robotics course. Now let's start with the working of sensor. Let's see how to interface sensor and how the sensors are working in real life.